little bit more professional. Okay, so for the other end of testing for water, we have created a device that allows you to automatically read chemical test strips used for testing water and report them to a web interface. I'm Joseph Hines. This is Gabriel, John, Chance, and Orlando. And so a little bit about these chemical test strips. I don't know if any of you have had a pool, and you might be familiar with these, but essentially they're these small pieces of paper with different chemical tests on them that are different colors. And what you do is you take these strips, dump them in a pool, aquarium, tap water, there's a wide variety, and you take them out and you compare them to a color chart to figure out what is in your pool or what is in your aquarium or so on. So there's a few issues with this. One, you have to match them yourself, and sometimes that can be difficult, especially for those with color blindness. And another is, once you have the results, you don't have a place to report them or do anything. You have to do that yourself. So what we have created is a system using a Raspberry Pi and a Raspberry Pi camera in a controlled lighting environment that can read these test strips, report them to a web interface for the user to understand, and then from there the user can take corrective action depending on the chemical results. To talk a little bit more about our solution and results, I'm going to hand it off to John.
Okay. So to communicate with a database where we send the data, we have REST API, and it's hosted on the board, and we basically communicate with the various components inside it. So we have a lighting environment that's established using basically LEDs to do a flash camera, so that way we can have the colors read in a white environment, hopefully. And we're trying to have a standardization for that in the other model that we have, but we have two solutions right now. One of them is a portable unit that you can just wet a strip and stick it in there and it will read the data. And we have a larger unit that has a servo-mounted cylinder with vertical inserts, and it basically manipulates the strips and brings it in front of the camera and also a water pump, so that way they can be tested. And the data presented there for the performance metric is a bit old. We've actually got it down to about 3% error rate with a different kind of algorithm. And so hopefully that will improve later. I believe that's for our data, the way it's presented, we have several graphs that will be on the website. They'll be telling you over time what kind of results you're having. You can have it scheduled, and it'll also have a threshold where it tells you exactly whether or not you should have your water adjusted. We have right now a range reply that will basically give you a range between two values of what the colors that are represented on the strips. Is there any questions?
Does physical mean human inspection, visual inspection?
And how do you quantify a human error?
Actually, the physical in there actually means so we have two types of tests. We did both software testing and physical testing using the device. So the physical testing on there is showing the device results. So that was getting about, what was that? It was getting about, with just raw, like if it got the right test, it was getting about a 50% error rate. But what we did later is we added it so it could go between two tests. So if it wasn't sure, because these colors, there's a discrete range, but there could be a bunch of colors between them. So it actually reports two of the tests between them, and that brings up the accuracy a bit. But raw just, does it get the test exactly right? It's about a 50% error rate.
I guess what I'm not clear is what's the difference between these two columns? What do you
Okay, so the software is actually, we made a simulation suite of software that runs through about 1,000 tests. And it generates different test strips, and it then runs it through our algorithm to see if it works, how our algorithm works, or actually our algorithm performing.
So how much improvement you made with the current system being used versus new?
So right now the system is about 2.6% error rate for 6,000 tests, so about 160 of them will fail. They'll be outside the true range that they were supposed to be reported at. And we can try and, it actually comes from linearly scaling all the tests using color correction. I noticed when I looked at the data that we can actually do them independently and then probably have a really good score almost perfectly, especially before we opened it up to a variance between colors on the chart. We had basically perfect tests until we started varying the colors more. Yes.
Okay, just a quick question. I see, two diagrams of boxes, but what kind of hardware is actually underneath there?
They're both using Raspberry Pi and Raspberry Pi cameras. In fact, the lighting environment between them, I wish we had a picture on here, but we have an open one at our booth. But they're actually using Raspberry Pi cameras with LEDs, so it's actually the same hardware inside.
Okay, and the last quick question is, do you do anything to calibrate either initially or over time for the variation and sensitivity of the LED lighting sources?
We do initial calibration. We do not. It was outside the scope to do calibration over time as the LEDs decay.
We have an optimization program that can run through tests and then see which color shift will give you better result, basically. Yeah.
Thank you.